Now we had question 2, and now we're at question 2, and question 2 mostly deals with factorization. So it says simplify completely 3p squared times 4p to the 5th. So we're going to say 3 times 4 is 12, and then p squared times p to the 5th is p to the 7th. All right, so that's 12p to the 7th. Easy question, soft. All right, then you go to part 2. Looking at part 2, they ask us to simplify this. 3x over 4y cubed divided by 21x squared over 20y squared. To do this, this is going to be 3x over 4y cubed, 3x over 4y cubed, and instead of saying divide, it's going to be multiply by, we flip it. When you divide, you flip it and change the sign from divide to multiply. So it's 20y squared over 21x squared. All right. Now this is where we're going to do some simplifying. Now this 3 cancels with the 21 to leave 7. All right. And this 4 cancels to get 1. And 20 over 4 is 5. So we get 5. All right. So in reality, what we're getting is 1 times 5y squared, which is 5y squared. And then it's being multiplied by x. And it's divided by 1 times y cubed times x squared. So it's 7y cubed times x squared. Now, we're pretty nice now, because what happened is, as you can clearly see, a x will cancel a x from the denominator. Y squared cancel y squared from the denominator. So we're left with 5 over 7 times y squared gone out of the denominator to leave y, x squared gone. Well, we're left with now 7xy. All right, 7xy. It's 5 over 7xy. Y squared over y cubed is 1 over y. X over x squared is, as we say, x over x squared. And so that's what we have. So we're doing pretty good. That takes care of that question. Nice and easy. Now this question says solve the equation for x. Well, it didn't say solve for x, but clearly x is the only unknown. So we have to assume that x is the unknown they're talking about, because we know what are 3, 1, negative 1. So we're going to be solving for x. Now, there are many ways you can do this question. Many ways. Now, first thing I like to do is write them as one fraction. I love to write them as one fraction. So I'm going to find the LCM. The LCM of 7x minus 1 plus 1 over x. The LCM is going to be x times 7x minus 1. I love to do that. Write it as one fraction. When you write it as one fraction, it makes it so much easier. And then we're going to say 7x into 7x minus 1 into the denominator, that leaves x. So then it's 3 times x, which is 3x, plus, now x into this is going to leave 7x minus 1. And 7x minus 1 times 1 is just 7x minus 1. Now all you have to do is now add the numerators, and you're going to get 7x plus 3x is 10x, and the numerator will have 10x minus 1 is equal to 0. Now I can completely ignore the denominator. I can completely ignore the denominator because think about it this way. No matter what the denominator is, once the numerator is 0, then the whole thing is 0. All right, so therefore I can always ignore the denominator. So if x over 9 is 0, then clearly x must be 0. All right, I'm just showing you some other example that we can just ignore the denominator because the denominator doesn't trouble anything. So we can ignore that to say 10x minus 1 is equal to 0. And if 10x minus 1 is equal to 0, we can actually solve for x. So now that we can solve for x, we can go ahead and say that 10x equal 1. And if 10x is equal to 1, then x is equal to 1 over 10. X equal 1 over 10. Now, when you finish this question and you're not sure if your answer is right, go ahead and check it back in the calculator. Go ahead. So I can check it back in my calculator to say 3 over 7 times 1 over 10 minus 1 plus 1 over 10. When I add them, I'm getting 0, and so I know that x is indeed equal to 1 over 10. So this answer is right. That's 3 marks. Easy. Now, we're looking at part C. Part C says, when a number x is multiplied by 2, the result is squared to give a new number y. Express y in terms of x. So we have some number x is multiplied by 2. So we have 2x. This result that we get is squared to give a new number y. So 2x all squared is y. So in reality, y is equal to 4x squared. All right, that is y in terms of x. All right, y is equal to 4x squared. Now it says determine the two values of x that satisfy the equation y equal x and the equation we derived in part 1. Now again, many persons might wonder, how did we derive this equation in part 1? It says x is multiplied by 2. See it there? 2 times x. Then the result, meaning the new number 2 times x, is squared to give a new number y. Now 2x all square means 2x times 2x. 2x times 2x is 4x squared. So that's how we get the 4x squared. Now determine the values of x that satisfy the equation y equal x and this equation. So they're telling us that we have another equation, y is equal to x. Now if y equal x and y equal 4x squared, then it says determine the two values of x that will satisfy this equation. So we're going to end up have 4x squared is equal to x. Now how do I know that? If y is equal to this and y is equal to this, then the two things must equal, man. Then the thing have to equal, don't it? Y equal this and y equal this. Then the two things must equal, x equal 4x squared. So we can carry over the x to get 4x squared minus x, and that is equal to 0. 4x squared minus x is equal to 0. Now that 4x squared minus x is equal to 0, we can factor out x. Factoring out x, we're going to get 4x minus 1. So x times 4x minus 1, and this is now equal to 0. All right, so x times 4x minus 1 is equal to 0. So the possible solutions for x are x can be equal to 0 or 4x minus 1 is equal to 0. And if 4x minus 1 is equal to 0, then the only number this could be is that x must be a quarter. X must be a quarter because 4 times a quarter is 1. So x has to be a quarter. All right, if x is a quarter, we get a quarter minus 4 times a quarter is 1. 1 minus 1 is 0. So x has to be a quarter. All right, so these are the possible values of x. They didn't want the possible values of y, they just want the possible values of x. So x is 0 or x is a quarter. That's all they said. All right. Nice and easy. They didn't ask for the possible values of y. They just wanted the two values of x that will satisfy the equation.